Hello, my name is Vahab, and welcome to the course Artificial Intelligence for Health Sciences. This course provides a comprehensive introduction to artificial intelligence for health science professionals, emphasizing hands-on experience with no-code tools. Participants in this course will explore the foundations of AI, the role of data in health sciences, practical applications of machine learning, large language models, and the ethical and regulatory landscape of AI in health sciences. The entire course comprises several modules, and this is the third module, machine learning or AI modeling. In other modules, you will learn about large language models and ethical and regulatory issues in machine learning and artificial intelligence. The primary objectives in this module are explaining machine learning model types and the workflow in a machine learning project or research, how to build machine learning models with zero-code tools, and after building the machine learning models, how to interpret the model performance. This module has two main parts. In the first part of this module, we present an overview of machine learning, and later, in a separate part, part 2, we'll have hands-on demo and experience running a machine learning model without any code using real data from health sciences. In this first part, we introduce machine learning and artificial intelligence, different types of machine learning, including supervised and unsupervised learning, two models, regression and classification, and also the evaluation metrics such as accuracy and confusion metrics. We first begin by defining machine learning. What is machine learning? Machine learning is a branch of artificial intelligence where computers learn from data to make predictions or decisions without being explicitly programmed. Machine learning involves feeding large amounts of data into algorithms that identify patterns and relationships. Essentially, we can say that machine learning is like teaching a computer to learn from experience, similar to how humans do. You might have heard about artificial intelligence, machine learning, deep learning, generative AI, and may wonder how they are related. This chart shows the relationship between machine learning and artificial intelligence. We can say that artificial intelligence is an umbrella term which includes machine learning and deep learning as tools. So artificial intelligence can be comprised as using different tools, including machine learning, to achieve automated decision making based on data patterns. So when we say that we are doing machine learning, it is part of the artificial intelligence sphere. Machine learning can be broadly divided into two types, supervised learning and unsupervised learning. In supervised learning, we have the truth or labels and supervise the machine or the computer with those labels if the machine can reproduce the truth or labels and how accurately. On the other hand, in unsupervised learning, we do not have labels or the truth and allow the machine to find the patterns in the data for us. Now, more details on supervised learning. In supervised learning, the machine learning model is trained using labeled data, meaning the input data is paired with the correct output. For example, imagine teaching a computer to recognize images of benign and malign brain tumor. You provide the machine with many images labeled as either benign or malign, and the model learns to identify the features that distinguish benign and malign brain tumors. Once the machine is trained, it can accurately classify new, unlabeled images as either benign or malign brain tumors. In unsupervised learning, we have a type of machine learning algorithm where the model is trained using data without labeled responses. For instance, imagine you have a data set containing various health metrics like blood pressure, cholesterol levels, and glucose levels collected from thousands of patients. Using unsupervised learning, the model can identify clusters of patients with similar health profiles, potentially revealing subgroups of patients who are at high risk for certain diseases. Let's look at two small data sets and see how supervised and unsupervised learning work. On the left-hand side, you can see a small sample of data. The labels include some animals like fish, bird, and human. And there are three features or characteristics, or in statistics we call them random variables. If the animal can swim, yes or no. If the animal can fly, yes or no. If the animal can talk, yes or no. For example, in the first row, the animal can swim, yes, cannot fly, no, and cannot talk, and say it's a fish. In the second row, the animal cannot swim, it can fly, and it cannot talk, so it's a bird. And in the third row, the animal can swim, it cannot fly, it can talk. It's a human. Now, in supervised learning, the machine can look at the labels and associate the labels to the features. Therefore, when the machine is given a new task, like the row here, it finds that the animal can swim, it cannot fly, it cannot talk. And because it has already learned that such an animal is a fish, it assigns the label fish to the new data points. Now let's look at an unsupervised task. In this data set on the right hand side, you can see the same data but without labels. When we don't have label, it is unsupervised. So the machine does not know the results. But the machine can look at the features or the patterns. For example, in the first row, we have a pattern Y, N, N. In the second row, we have another pattern N, Y, Y, N. So the machine decides there are two different categories. Here we have used colors to distinguish them. Or in the third one, the pattern is Y, N, Y. So it can swim, it cannot fly, it can talk. Now the machines have learned these patterns, and now we are giving the machine a new data point, so Y, N, N, and the machine looks at the data patterns it has learned before and produces a category for these new data sets. So from three categories, the machine chooses the yellow one because Y and N is similar to the yellow one here, Y and N. And it gives a new category to the data point. Now let's look at the workflow for a machine learning project. The first step is asking the right question. Then, based on the question, we gather data, select the machine learning algorithm, train the model, test the model, and if needed, refine the model again. The most important step in a machine learning workflow is the purpose of the research or the project, because the data to be collected depends on the research or project purpose, and all other steps in the workflow depend on the data. Next is the data step. Depending on research question, data may include continuous variables like blood pressure or BMI, categorical variables like gender or race, images like MRI, CT scans, text such as clinical notes, patient complaints, or sound like heart sound. Depending on the data, the appropriate machine learning algorithm may include regression, classification, clustering, or generation of new data. Next, we train the model. Once the data and appropriate machine learning models are selected, the model is trained on the provided data and passed on to the testing stage on realistic data to evaluate its performance. Once the machine learning model is trained, its performance will be evaluated on new or test data to see how it performs in more realistic settings. If the tested model is not performing well, we may still save the model by tuning some parameters or transforming data or eventually replacing the model with another machine learning model. In this module, we have hands-on experience with two machine learning models, regression to predict continuous outcomes, and classification to predict a category of outcome. Regression in machine learning is a technique used to predict continuous values, such as blood pressure or cholesterol level based on input data. It involves finding the relationship between dependent and independent variables to make accurate predictions. Essentially, regression models learn from existing data to predict future outcomes. The most common metrics to evaluate the performance of a linear regression model are root mean squared error, or RMSE, which measures how far the model is from a perfect model. Another metric is R-squared, which indicates the proportion of the variance in the dependent variable that is predictable from the independent variable. It is interpreted in the range from 0 to 1. Classification in machine learning is a technique used to categorize data into predefined classes or labels, such as survive or not survive, benign or malign tumor. It involves training a model on labeled data so that it can learn to distinguish between different categories based on input features. The most common metrics are accuracy, precision, and area under curve. Accuracy measures the proportion of correctly classified instances out of the total instances, and precision indicates the proportion of true positive predictions out of all positive predictions made by the model. The area under curve in classification is a single number that measures the true positive predictions. It ranges from 0 to 1. In conclusion, we can say that learning machine learning equips health science students with the tools to analyze complex medical data, leading to faster and more accurate diagnosis and personalized treatments. It fosters innovation in developing predictive models for disease outbreaks and patient outcomes, enhancing public health strategies. Mastering these skills empowers future health professionals to leverage technology for improved patient care and healthcare efficiency. Thank you so much for your attention. In the next module, we'll have hands-on experience with machine learning models.